Having studied our basic visual analysis of data, we'll now move on to a more theoretical analysis. Now, this can be a little bit heavy if you haven't seen it before. Some of the definitions look very complicated. I'll try and explain the definitions at an intuitive level, and then we'll move on to a separate submodule where we work through several examples. So you'll really get to see how to compute with these things quickly. What are statistics? Well, statistics are used to summarize, analyze, or interpret data. If you have a very large data set, and we're living in this era of big data, so certainly one can talk about having data the size of many gigabytes or even terabytes. It's way too much to handle. What you want to do is summarize it and say, instead of looking at all the data, all I need to know are things like the mean, things like the median, things like the variance. In reality, these are not perfect. You cannot completely summarize all data with these basic statistics, but they're extremely useful for sort of making informed decisions without having to look at every data point. Every scientific discipline makes extensive use of this. If you look at any scientific journal, any economics publication, even business articles, they'll make very heavy use of statistics. So it's not just mathematicians who care about this. It's fundamental to thinking about knowledge in the current world. We'll focus on a few basic examples that you would see in an introductory statistics course at the university. We'll focus on measures of center and measures of spread. Measures of center try and give you a notion of what one number best captures my data. You can think of these as things like the mean, the median, and the mode. There are other measures of center, but in some ways these are the most fundamental. So if you're not familiar with these, we'll review them now. Let's say that we're given some data points, x1, x2 through xn. For example, let's say we're given the points 1, 4, and 6. A nice small, nice small data set. What is meant by the mean of the data? It's just the average. Mean is the mathematical way of saying average. So what I do to compute the average, or the mean, I take all my data points and I add them up, and I divide by how many things I have. That's the mathematical formula that's written here. I go x1, x2 through xn. I add them all up and then divide by n. So it says add up all data, then divide by number of points. More compactly, you typically write it like this, where this sigma notation denotes adding everything up. So that's the mean. Every element gets to contribute equally. This is in distinction to the median, where different elements don't necessarily contribute equally. How do I compute the median of data? Well, this is just the middle number. So what number is smack in the middle of all my data points when I put them all in order? So an important point here, the data has to be sorted to do this. So to compute the median, I start by sorting all of my data points. It doesn't matter if you go from smallest to biggest or biggest to smallest, though I do recommend smallest to biggest. It's more conventional. Once you've sorted the data, you pick out the middle number. Now, there won't always necessarily be a middle. There could be two numbers in the middle. This will happen anytime you have an even number of data points. In that case, the median is the average of the two middle numbers. So if n is odd, you take the middle. If n is even, you take the average of the two middle numbers. So something where we have to do a bit of computation. We have to sort and then pick the middle. The mode is the easiest one to compute. It's the number which appears most often. It's possible to have more than one mode. If different values appear the same number of times, and they're both the most common, those are both modes. So unlike the other two where we typically return a single mean and a single median, you can return multiple modes. Okay, so I'll just make a remark about that. Multiple modes is possible and it's informative. knowing that data has, for example, 2 modes is very helpful. In fact, there's a special name for this type of data. It's called bimodal. This makes sense. Bi for 2, modal for modes. So this is, again, different from medians and means. Multiple modes is possible. So measures of center give us a way of saying, return to me some numbers, or in the case of mean and median, 1 number, in the case of modes, potentially more than 1, that summarize sort of where my data is centered. Measures of spread give us a notion of, are most of the data points close to this measure of center? Are most of them far apart? What is the concentration of the data? So it's a bit more of a geometric property. Okay, so to summarize, it's a measure of spread is a measure of how spread out the data is. So is the data concentrated around the, let's say, mean or median? Or is it spread out or diffuse? So what are some measures of spread? Well, actually, we have some that correspond to the median and some that correspond to the mean. The ones for the median are simpler to compute, so I'll do those first. Measures of spread corresponding to the median are essentially percentiles. We will focus on the 25th and the 75th percentile. So what you do for this is you sort the data and take the number at the 25% point, i.e. the median of the first half. For the 75th percentile, you take the median of the second half. So these two numbers sort of tell you where the middle 50% of your data lives. The difference between the 75th and 25th percentiles is called the interquartile range. It gives you some idea of how closely your data is concentrated around the median. Another nice indication of measure of spread is something simpler, called the range. This is just the maximum value of the data minus the minimum value. What's the biggest you can get? What's the smallest you can get? Now this is nice, but it's not robust to what we might call outliers. If I have most of my data in a very narrow range and one value that's much bigger, then the range is going to tell me I have a very large range. But in reality, most of the points are very concentrated. So this is why we also talk about the interquartile range. Now, these can be plotted in a very standard way with what's called a box and whisker plot. So here I'm geometrically representing my data. This value here is the maximum, and this value here is the minimum. So what I have is at the very top, the maximum value, at the very bottom, the minimum value. So I can see the range, for example. It's the difference between these. But I plot more information with this box and whiskers plot. I also plot the 75th percentile and the 25th percentile. This lets me know points that are within 50% of the median. So I can see, for example, the interquartile range. Finally, this red bar here is the median. So I get to see through this the measure of center, the median, what points are the 50% that are closest to the median, that's the interquartile range, and then I also get to see the full range of the data by going all the way out to the whiskers. So I think it actually rather useful representation. Now, the notions of measures of spread like interquartile range and range, These correspond to the median. There are also measures of spread that correspond to the mean. Now, these are a bit more delicate. They involve what's called the variance of the data. So let's look at the definition. We say that for a set of numerical data, the variance is given by this formula here. I take each individual data point, subtract the mean from it, and square it. I add up all those squared differences, and I divide by the number of data points. So you can think of this as the average squared distance to the mean. Okay? So for example, if my data points are 1, 2, and 3, then the mean x bar is 1 plus 2 plus 3 divided by 3. So 6 over 3, which is equal to 2. And then the variance is 1 divided by 3 because I have 3 data points. And then what does this sigma sum correspond to? Well, I do the first data point, 1, minus the mean, squared, plus the second data point, 2, minus the mean, squared, plus 3 minus the mean, squared. So 1/3, this is 1 plus 0 plus 1. So the variance is 2/3 in this case. So this is measuring how far away on average my data points are from the center. These squared distances measure how far away you are. And then I average them to say that each point counts equally here. Once I have computed the variance, we can compute something called the standard deviation, which is maybe a term that you've heard of. The standard deviation is just the square root of the variance. Okay? So all I do to compute standard deviation is take the variance and take the square root of it. So the first step to finding the standard deviation is to find the variance and then take a square root. So we've introduced a lot of theory here. In the next submodule, we'll work through some examples to see this in action.